Hey folks, Mr. Dell here. We are trying to solve this word problem given a situation with some rates. So this is a problem coming from CPM's course 3, and this is closure. This is the chapter 10 closure, specifically number 10-79. It says two brothers, Martin and Horace, are in their backyard. Horace is taking down a wall on one side of the yard, while Martin is building a wall on the other side. Martin starts from scratch and lays 2 bricks every minute. Meanwhile, Horace takes down 3 bricks each minute from his wall. And it gives more information. It takes Horace 55 minutes to finish tearing down his wall. So you got two sides, right? Two sides of the yard. Over here is, I'll take some notes, Martin, and over here on the other side is Horace, and he's building his wall, and it says he's building. Martin starts from the scratch and lays 2 bricks, so 2 bricks per minute. Okay, so that's a positive. He's adding 2 bricks per minute. And then Horace is taking down 3 bricks each minute, so he's taking down, so that's he's getting rid of, so I would say -3 bricks per minute. So he's tearing down a wall, he's building the wall. It also gives some information. It says Horace takes 55 minutes to finish tearing down his wall. So that's going to give us a sense of how many bricks there were. So I think that's this question here. So how many bricks were originally in the wall that Horace started tearing down? So if it took him 55 minutes to tear down the wall, and he was doing it at 3 bricks per minute, right? I would actually take that 3 and multiply by 55, because it's 55 minutes, 3 bricks per minute. So when I multiply those two, I get 165. So that means there was originally 65 bricks on Horace's wall. Okay. All right. It says represent this situation with a equation or system of equations, but be sure to define your variables. So when I'm looking at a rate here, I've got two rates: 2 bricks per minute, 3 bricks per minute. Right? When you have a rate, a unit rate, your x is always whatever it's your time frame in this case is, because that's per minute, right? So if I'm going to define my variable, I'm going to say x is the number of minutes. And if I was multiplying the number of minutes times the number of bricks per minute, then that would give me my number of bricks. So if I wanted to figure out what my y is going to be the number of bricks. So I have two. I have Martin. What is Martin's equation? Well, his number of bricks, y, is equal to 2x. He starts with 0, right? So I could say plus 0 because he's starting from scratch. He doesn't have anything already started in his original. He's starting from 0, and then he's adding 2 bricks per minute. Now Horace, the number of bricks that are left on his wall, it would be defined as -3x because he's taking down 3 bricks every minute. And originally, though, we figured out up here, originally there was 165 bricks. So he starts with 165 bricks, but he's taking down 3 bricks every minute. At the same time, Martin is adding 2 bricks. He started with 0 bricks, and he's adding 2 bricks per minute. Okay? Because I'm a reminder, I'm pulling this all from this y equals mx plus b, which m represents that growth. That's always the growth rate. And b always represents the initial value, or the y-intercept on a graph, but it's that initial value. It's that starting point. That's what the m is the growth rate, and b is that initial value. All right. So then it says, when do the two walls have the same number of bricks? So what I've got is a system of equations that I want to now solve, right? I want to find out when what X would have the same Y? When would be there the same number of bricks? Why bring the number of bricks? When are those equal? When are those equal? So that's why I set them equal to each other. I don't need the plus 0. I can just say 2x is equal to negative 3x plus 165. I add 3x. I'm solving for x right now because I want to know what x would make this equation true, where the y's would be equal. So I have 5x is equal to 165. Divide both sides by 5. X is equal to 33. So at 33 minutes, then they had the same number of bricks in each of their walls. So we can answer that question. So at 33 minutes, the two walls have the same number of bricks. Okay, that's how we do it. There we go.